Okay, hello. This is a lesson on compound interest. Now, before we get into what compound interest is, it's important for us to kind of see how other people saw how important compound interest is. Albert Einstein said that the most powerful force in the universe is compound interest. That's a pretty darn strong statement. And then Benjamin Franklin actually said, when he described it, money makes money, and the money that money makes more money. So your interest makes money. So you're basically depositing money in, and then the money you make makes you more money, which is a pretty powerful idea. And we're going to talk about what that means in this lesson. So first, a few definitions. We've got investment. What is an investment? An investment is the use of money, and sometimes not just money, but capital. So the use of money or capital for income or profit. A fixed investment and a variable investment are two types of investments. A fixed investment is an amount that is invested, that is guaranteed, and interest is computed at a fixed rate. So let me write that down for you. The amount invested may be guaranteed, and interest is computed at a fixed rate, which means the rate doesn't change. Fixed rate throughout. This would be your typical savings accounts, a money market account, which you can get both of those at a bank or a credit union, bonds, those types of investments. So you put your money in a savings account, it sits there, it's a fixed investment. Now then we have what's called a variable investment, and a variable investment is when neither the principal nor the interest is guaranteed. Neither the principal nor the interest is guaranteed. This would be our stocks. So we've recently looked at stock values and how they fluctuate sometimes from second to second. You can see the value of the stock changing. Mutual funds, commercial bonds. These are all examples of variable investments. And variable investments, because they're not guaranteed, they are considered to be risky. So a bit of a high risk there with your variable investment. And then compound interest is the interest that is computed on the principal and any accumulated interest. So interest that is computed on the principal. So you put your money in the bank and you earn interest. And what the bank does is they just deposit that interest right back into your account. So if you started with $100 and you earned $3 in interest, you now have $103. And then the next cycle in which they are waiting for your money to sit there, they are going to calculate interest on the $103. And then that money is going to become greater. It might become $107. And then the $107 makes interest. So your interest eventually will make you interest. And that's called compound interest. So interest that is computed on the principal and any accumulated interest. So now that we're writing any accumulated interest, Hopefully you understand what that means. So what I was saying was if you deposit $100 and then let's say 3 months later, they computed your interest and your balance is now at $103. Then what's going to happen is that $103 is going to make interest. So the next time they compute it, maybe it becomes $107. So maybe the first time you only earned $3, the next time you earned $4, and the reason being is because they didn't go back to the $100. They're giving you interest on the initial investment and on the interest that you earned. And then this has interest and more interest. So the next time they compute it, they're going to compute it on your principal investment, which was $100, the interest and the additional interest, and they'll give you more interest. So that's compound interest, where your money makes money and then that money makes more money. So we're going to look at this without a formula. So Mrs. Bond works as a sales representative for Neutrogena. She recently received a $5,000 bonus for reaching her annual sales quota. Mrs. Bond invests the $5,000 in a 1-year certificate of deposit that pays 3% interest compounded quarterly. Determine the amount A to which the $5,000 will grow in 1 year. So I'm going to highlight a few things. We've got the initial investment of $5,000. So she's going to invest $5,000. She pays, the bank is going to pay 3% interest, and then it's compounded quarterly. So compounded quarterly is a big deal. Determine the amount A to which the $5,000 will grow in 1 year. So she's going to let that $5,000 sit there for a full year. So the amount that we're going to have is going to equal the principal plus the interest. The principal plus the interest. We're going to start with calculating our interest. So our interest for the first quarter, so quarter 1. Now 4 quarters in a year, that's 12 months. 12 divided by 4 is every 3 months. So the interest that she's going to earn is going to equal the $5,000 times the interest rate of 0.03 times the time of 3 out of 12. Because 3 months is at the end of the first quarter, they're going to compute interest. And when I put this into my calculator, so I'm going to show you on the calculator. So when we put this into the calculator, we've got the 5,000 times 0.03 times, and then I just hit 3 divided by 12 in parentheses. You could use the fraction bar, but I hit 3 divided by 12 because it's the same thing, and I press enter, and I get $37.50. So $37.50. So that's the interest that she earns. I'm going to keep it separate for this first one. The amount is the $5,000 plus $37.50. So at the end of the first quarter, Mrs. Bond has $5,037.50. And that amount is going to be computed upon in quarter 2. So quarter 2, we're going to start with $5,037.50. So now I'm looking at this formula right here. This way I can save myself some room. The principal amount is the $5,037.50 from the first quarter's computation. And then I need to add the interest. Now the interest that she's going to earn is $5,037.50 times the 3% times another 3 months out of 12. So we put that into the calculator. And I'm going to do this all at once. So I'm going to show you. We've got the $5,037.50 plus, now I'm going to calculate my interest. So that's the principal. The interest is 5,037.50 times 0.03 times 3 divided by 12. I press enter, and at the end of the second quarter, she has $5,075.28. So we're going to come back here. I want to say that's $5,075.28. That's the amount we're going to take into quarter three. So we're going to take that $5,075.28 and we're going to add it to a new amount of interest, 5,075.28 times 0.03 times 3 out of 12. So we're at the end of quarter three here. We put that into our calculator. And I'll let you put this into your calculator. And you should get $5,113.34. One more quarter to go, quarter four. The amount is going to equal $5,113.34 plus the interest of 5,113.34 times 0.03 times 3 out of 12. And when I put that in my calculator, I get 51.51 and 69 cents. So it asked, determine the amount A to which the 5,000 will grow in 1 year. And this is how much the $5,000 will grow to. It will grow to be $5,151.69. So things can be, we can take accounts and we can compound them quarterly. We can compound them monthly. We can compound them daily. So if we were to compound monthly over a year, we would do this 12 times, which is quite redundant, tedious, and not too much fun. If we had to do it daily, we could do this 360 times for a banker's year, 360 times for each day of the year. Again, that would not be too much fun and it would take quite a long time. So I'm going to show you a formula that we're going to use, which hopefully you will appreciate. The amount is going to equal the principal times 1 plus R over N raised to the N times T power. So P stands for the principal amount. That's your initial investment. R is your interest rate. N is going to be the number of times it is compounded in 1 year. So quarterly was 4 times because there's 4 times in a year. Monthly would be 12 times, so N would equal 12. Daily would be 360 times. And then T is the number of years that the money is accruing interest in an account. So if I take all of these values and I plug them in, my initial investment here, or Mrs. Bond's initial investment, was $5,000. So we put $5,000 times the quantity, 1 plus, the interest rate was 3%, so that would be 0.03, and then quarterly meant that N equaled 4. And then I'm going to raise that to the 4, which is n, times 1 power. So our time was 1 year, and our quarterly was the value of n. And I'm going to show you how to put this into your calculator, and if you practice it right now, you're going to go a little bit faster on the next problems. So we've got 5,000, and then 1 plus, I'll use my fraction bar, 0.03 over 4. And then I'm going to raise that. So I hit that upper caret key right here. I'm going to raise that in parentheses 4 times 1 power. And you can see we have 5151, and this is actually a bit more accurate to this. It would be 70 cents versus what we had earlier, which is 28 cents. Now the difference is if you go all the way back up here where we did some initial computations, this value right here was not what we brought in. So this 125, we cut that off. So every time we brought in a new value, we cut off part of the decimal, which gave us an inaccurate value moving forward. So when we use our formula, we're going to get a much more accurate ending value. Oh, okay. So let's practice using our formula. That's what we're going to do in the next video, compound interest formula. I'm going to give you that formula, and we're going to do a couple of examples. And in the next video, we'll also talk quickly about effective annual yield. That also is another formula, and you will be able to use your formulas throughout your assignments in addition to the test. So there is a formula sheet that will give you these formulas. You just need to make sure that you know how to use them. And that's what's most important in life, is that we can always find a formula, but how do we use them is going to be the most important part of being successful, especially when we're handling money, and especially when it's your money. So in the next video, we'll practice using these formulas.